Coming up from Microsoft, Stott is going to present us the session called One Endpoint, Many Models, Smarter AI with Foundry Model Router. So please welcome Lee, and let's see what he's going to present us next.
So first of all, I've got the really difficult act of following lunch, so please don't fall asleep. I'm going to try and make this quite interactive. So I'm Lee Stott. I'm a principal cloud advocate in Microsoft in our developer relations team. I work for Microsoft and GitHub. So if anybody doesn't know, Microsoft acquired GitHub in 2018. So we've actually joined the teams together. So the developer relations team is now Microsoft and GitHub, and Microsoft is helping GitHub from an engineering perspective. And we're also working with developers around the Copilot ecosystem. So hence I've got this jacket of GitHub and Microsoft, and people go, really? So yeah, that's why I'm wearing this jacket. So if we can go to brilliant. So on my slide. So a bit of agenda, what we're going to talk about today. First of all, I'm going to give you a bit of an introduction to Microsoft Foundry, which is our all-up AI solution. Then I'm going to talk a little bit about agents and where agents are today. I noticed, from the calls and talks earlier today, not many people are using agents. So I just want to outline what an agent is, what the current challenge is, and what the solutions are. Then I'm going to focus on the Microsoft Foundry and model types and the variety of models that are out there, because again, some of you might not understand the different types of models. And then I'm going to focus on Moderator. So Moderator is a new service that Microsoft is offering to try and help developers really get over this issue of just model fatigue and the issues of which model do I choose. So let's start off by a quick overview of what Microsoft Foundry is. So as I said, Microsoft Foundry is our all-up AI solution. So this is all AI services, technologies, and products from Microsoft, from GitHub, from LinkedIn, all live within Foundry. So we start off at the very top with our developer experiences. So we've got GitHub, Visual Studio Code, which I call full fat. So if you hear me say Visual Studio Code, Visual Studio full fat, that is Visual Studio. That's a big product. We have Visual Studio Code, and then we have Copilot Studio. So these are the different ways developers are building on our ecosystem. We then have the core pillars. So we have models, which models come from everywhere. So they come from Hugging Face, they come from Anthropic, they come from Google, etc. And they all sit within the model catalog. We have agent services. That's where all our agents live. We have this thing called IQ, and IQ is our new terminology for any knowledge. So that could be knowledge in our data sources, like Fabric IQ. It could be knowledge in search. Anybody who used Azure Search is now called Knowledge IQ. So that's all our data. Work IQ is about all our data within M365. So we bundled everything under IQ. We then have tools. So anybody using MCP? Cool. So a few using MCP. Anybody using skills? Cool. So they all live within tools. So that's where a developer can go to a catalog, to marketplaces to find skills, find MCP servers. And then we have our traditional machine learning. So anybody building custom models or fine-tuning models, you do that within the machine learning side. We then have our marketplace and service offerings. So we've got thousands of applications being built by you as developers or you as ISVs. And they're then made available to customers through the marketplace. So SAP, SAP, UiPath, Microsoft Bing, Microsoft Fabric, ServiceNow. So a lot of the technology that you're probably using on a day-to-day basis is probably being served through that product catalog. We then have control plane, and control plane is about the control of all these services. This is the observability, the evaluations, the monitoring of each of those services. And then we have our security fundamentals at the bottom of it in terms of Agent 365, Defender, Purview, and Entra ID. So everything is wrapped within that security layer. And this goes from cloud to edge. So everything I'm talking about today, you can either do it in the cloud, you can do it in sovereign data centers, or you can do it at the edge if you're running your own data centers or your own localized compute. So when lots of organizations come to us, they say, our developers are really struggling with this current era of agentic AI. And we try and really pivot around these four key pillars. So, number one is about mindset, continual learning. So I don't know how many of you feel a bit burnt out by technology. It's changing on a daily basis, but developers need this new mindset. You're coming in, there's going to be a new day, a new model. It's guaranteed. It's no longer non-guaranteed. Again, skill sets are changing. Who as a developer in the room thinks of themselves still as an individual contributor? Does anybody still think, I'm a developer, I work on my own? You're a manager of agents now. In the future, you will see agents within your organization structures as identities. I already see my agents as identities. I've got 40 agents in my identities. So you are now a manager and a custodian. So somebody asked a question earlier about who is responsible if something goes wrong. You. You built the agent. You're running the agent. You are now responsible. You're a manager. Tool sets. Tool sets are changing every day. Who knew about skills 6 months ago? Who knew about MCP 18 months ago? We have to be continually building and learning these new skills and new technologies, these new protocols, these new open source standards. Data sets. Anybody who does, anybody's going to be building an agent, so the majority of you in the room, if you do not have tagged, identifiable data, do not build agents. It's garbage in, garbage amplified. Okay? It's not garbage in, garbage out, it's garbage more, because these LLMs will hallucinate. Data sets are so cool, are still cool, and they're still so key. Data is still gold. So data is your fundamental thing. Do I trust the data? Is the data tagged? Is the data appropriately stored? Do I understand my data estate? In terms of Azure, we've got data centers across the world. Anybody who's reading like the stock market, Microsoft is spending $68 billion a quarter building data centers. So anybody says, I'm going to build a data center, build a data center. We're building hundreds. We're making that level of investment because technology is advancing so fast. GPUs are coming out every single day. AMD released Halo. NVIDIA have released RTX, DGX. They're all the Blackwell stuff. It's massive. There's massive investment going. And again, data center regions are so key, especially in Europe, around sovereign data centers. Lots of organizations and countries now want to keep their data within their custodianship. And this, again, was amplified last week by the Fable 5 announcements. Anthropic wanting to retain data. Lots of organizations now have banned, smiling, lots of organizations have banned the use of Fable. If you're non-US, you can't get access to the product anymore. So again, there's lots of changes around how model providers and hyperscalers want access to these resources. If you look at the stack, this is the current AI stack. It doesn't really matter if it's Microsoft, Google, IBM. We're all pretty much the same in terms of how we're positioning this. At the very top, it's all about experience. It's about you as developers building the best experience or having the best experience at building agents. We then have our agent platforms. And this is really the way you as developers build agentic solutions. So if you're using Claude, if you're using Cursor, if you're using Windsurf, if you're using GitHub, there's so many choices now, but it all fundamentally comes down to models. Which model are you going to utilize? Which is the model provider? Where does the model live? And then what tools and services are you going to put onto that model? And it really comes down to this final piece, AI token factory. So who's really upset by the GitHub announcements of token-based economies? Be honest. I've been burning billions of tokens. I'm very lucky. I can afford to burn billions of tokens. But for you, we have to think about, number one, are we cooking the planet? Are people using the most appropriate models? And this is why we've turned on things like auto model. Because if you're running a bash script, do you really need 4.8 or 5.5? But developers were doing it. Developers were doing it, honestly. So again, we want to start educating people about, what is the best use of this AI technology? What's the best use of the models? Token economy has to come into play. Okay, so if we look at agents today, so stick your hands up and keep your hands up if you're in this category. Who has never built, deployed, or run an agent? So put your hands up if you've never built, run, or deployed an agent. Okay. Who has built a single agent? There's not many of you. Okay, there's not many. There's about 10 people who've done this. First thing, right, you probably all, anybody who's like used a chatbot is in the first column, no agent. You've done a simple Q&A with a knowledge base. You've got a chat interface and it's giving you the answers. Single agent, 10 of you have done it. This is really where you start to use an LLM using some form of knowledge or documents or RAG to build that agent solution. We're now in this multi-agent solution. So who's built a multi-agent? Okay, that's good. So there's more of you built a multi-agent than not built or built a single agent. Now, the benefit of multi-agent is also multi-LLM. So those who have put their hands up, how many of you are actually using different models for different agents? Excellent. So the majority have got this problem. It's a big problem. Developers build an agent, they choose a model, they then implement the agent. How many of those people have gone through model deprecation? So the model that you chose is, oh, brilliant. Okay, so you were a 3.5 user. Yay! Okay. So this is a really key thing, okay? Model deprecation is real. Microsoft, Google, AWS will provide a model for 1 year guarantee. The 1 year, that model goes away. This is down to capacity. Model goes away, new models come in. As I said, we're at a model every day. We've got lots of capacity that's needed to get these models out there. So again, this is why you see application forms for capacity allowance, applications to apply for a model availability, because capacity is so constrained. So if we look at agents, these are the developer challenges that we see. So it's like, anybody who's not built an agent is probably going, yeah, I agree with all these. So where do I start to build an agent? How do I connect to an agent? How do I make the agents work together? How do I know what an agent is doing? How do I deploy and manage agents? And then how do I actually build it? How do I get started? Agree with all of those? Yep, everybody's nodding, which is good. So if we look at agents today, these are the types of solutions that's available. So as Microsoft, we have Microsoft Agent Framework, which is about how to wrap and orchestrate agents together. So if you're building that multi-agent environment, whether you're using LangChain, LangGraph, LangChain 4j, Microsoft Agent Framework will support you bringing all those agents together to wrap them in a single orchestration pattern. We have tools like MCP and A2A, which allow us to build those multi-agent workflows, calls, tools, and services. Telemetry, if you're building it without observation, don't build it. I always talked about it earlier on. Observability and evaluations are really key. And then the other thing is, once you've built it, where do you put it? And this is where hosted agents come in. We allow you to publish an agent with one button click or a single command and have that hosted as a service. And then you've got these other things like ChatKit, AGUI, which are basically agent UI workflows. So drag and drop workflow orchestrators to allow you to build agent-based solutions. So again, depends on if you're a code-first developer, a UI developer, a drag and drop developer. We're trying to cover all those different aspects. So if you look at this from a Foundry agent perspective, we've talked about build. So you're going to build a multi-agent using framework. You're probably going to use something like the Copilot SDK, or you're going to use Claude, or you're going to use Cursor. You're going to use third-party frameworks and models, and you're going to use some form of SDK. You're then going to host it, so you want to host it as quickly as possible and not worry about scalability. You just want to publish it, and if it becomes really popular, the service auto scales. If it's not being used, it scales down and saves you cost. You want to ground those agents in knowledge and data. So this is where the IQ services come in. You want to have search, you want to have RAG, you want to have entity knowledge, business understanding. You want to access tools, MCP, skills. And you want to give your agent memory so that the agent remembers context, which reduces your tokens in and tokens out. And again, you want to be able to publish it to anywhere. You want to publish it to any channel you want. So where are we today? Foundry Catalog has over 11,000 models. Which model do you choose? How do you select a model? Does anybody have this problem at the moment and going, which model do I deploy? Okay, so there's lots of things like, it's a massive issue for developers. It's a huge decision fatigue. How do you go back to that business decision maker and say, I chose this model? What was the reasons? Well, it was the best model. Why? It was the cheapest model. Was it the most performant model? So first steps that we want to really start thinking about is looking at your approach. So what we see is organizations frequently have a single LLM provider. So lots of organizations come to us and say, we're Anthropic or we're GPT models. Quite an easy decision then. These are the models that you can have. Again, workflow scenarios really range around 3 factors: quality, cost, and performance. So again, you want to be able to search and identify models which relate to those. And then you've got the consequences. If you use a model that's too big, so if you're using like GPT 5.5 to do a customer agent bot, and when 90% of the customers just say hello or hi, can you help me with? Are you using the most appropriate model? So what you get from a decision maker perspective as a developer is lots of questions like this. It's like demand for cost efficiencies. This has to be cheaper. This has to be faster. They don't want to know about model overload. That's not their issue. That's your issue. They want to have better governance. They want to have better governance of their systems and services. And they also want to balance speed and quality, because speed and quality results in NSAT. Are customers happy? Will customers come back? Will customer buy from us? And then it's really around that model operations and GTM. They want you to get that out the door and ready. Like, get it shipped. Make it live. How can you make that faster? So if we look at the models that are available, we have 2 basic types of models. We have large language models and small language models, LLMs and SLMs. These are really general purpose. They can do pretty much any sort of task. Once we start to break these down, we end up with these pillars. So we have reasoning models. So these models are really optimized for logical thinking. They have that thought process. They'll take a problem, analyze it, and come back with suggestions. We have multimodal models, so the ability to do image and videos. And then we have coding models. What you will see is codexes. So these are principally the main types of models that are available. So once you start having this problem, it's like these are the filters that you should use in the benchmarking tools to then say which model should we implement for our agent. So what are the conditions of when you should use this? So foundation models, high speed, high throughput, workloads that require fast, concise responses, and a general purpose task. Or reasoning models, where you're moving into this multi-step problem. I think everybody's sort of moving to reasoning models, to be honest, now. I don't think anybody's using the foundation models anymore unless you're doing very specific tasks. When it comes to availability as well, this is quite an important one for that cost decision-making process. So we have 3 different ways of provisioning models in Microsoft. Again, other cloud providers are very similar. So we have standard, which is basically you choose standard, and it will literally publish the model, and it's ideal for most use cases. It's the most cost-effective way of deploying the model, and it's not really for high-scale production. It's medium load. So again, going back to capacity, this is running on machines that are hot. The models are going to be available, but it's not high throughput, high consumption. They're good for production workloads, development and testing and prototyping. Provision is really where you want dedicated provision compute sitting on those models. So those models are going to be hot, they're going to be available, they're going to be really fast. It's pretty expensive because you're paying for that dedicated compute time. But again, if you're running production systems, NSAT's going to be key. You want to start thinking about, do you move to them? Is it a high volume workflow? Do you definitely move to it? If it's going to be a heavy throughput, definitely move to it. Real-time applications, definitely move to it because you don't want the latency. And then we have batch, and batch is about like spot pricing. It's the most cheap way of doing something, but it's really where you want to do something long-running agent. So you might have a process task that runs. It has to run between 6 p.m. and 8 a.m. You don't care. You give it that batch process system, and it will run. It's really about high-volume workloads, like big tasks, like a financial consolidation or an audit report, perfect for batch. So key things about models is, you've got to think about data privacy, security, and responsible AI. Lots of people have talked about responsible AI, but not call it responsible AI. It comes back to that thing of just because we can build it, should we build it? And if we're building it, where's it going to be stored? Where is the data that's going to be in your estate? Where are the models? They're going to be in your estate. What's the security and compliance around it? Your security and compliance with your Entra IDs. That's what Microsoft offers in terms of those 3 pillars. So let's talk about Model Router. So we've seen the complexity of like, which model, how do I get access to it, which one do I choose? And what we've done is we've actually purposely trained a language model that will analyze the prompt that comes in real time, and then choose the best model from the selected models that you want to utilize to then deploy this. So at the moment, so this is really new, at the moment we only support 28 models from them 11,000 models. It's nearly 12,000 models. So we've gone through and looked at the benchmarks, looked at what people are utilizing and gone, okay, these are the most common types of models. It's really about that customized logic. So we've said in our algorithms, we're going to basically have 3 measures. We're going to have cost, quality, and performance. So you can select cost, quality, performance, all 28, or just a section of the 28. Again, we want it to be fully native in our applications, so it's got full support for our agent services. So if you want to have an agent, the agent can talk to Model Router to then route to any of these 28 models, because that's a real big complexity when you start building agents, because an agent has to have a model endpoint. We allow you to choose Model Router, which will then appropriately route the prompt to the right model. And it has to be enterprise grade, so it has to support security, observability, evaluations. So these are the models that are currently available in Model Router. So it's all the OpenAI family, every single model, so 18 models, maybe more next week. Anthropic models, so we support 5 models. So we support Opus, Hakai, and Sonnet. We have 2 models from xAI, so the Grok models. We have 1 model from Meta and 2 models from DeepSeek. All these models are secure models. They all live within Azure in Foundry. They all live within your Azure subscription. We do not take any of the data from any of these models. They are your models. They're just hosted on our platform. So let's have a quick look at Model Router and how it works. I'm going to just jump over to this. So this is my Azure Foundry. So I'm just going to do a refresh because it might have timed out. And in here, what I can do is I can go to deployment. So if anybody's used Foundry, this is basically where you deploy models. And you can see I've got a number of different models deployed. So I've got GPT-4 Mini, GPT-5.5, I've got a text embedded model, and I've got the Model Router. So I can literally just deploy any model I wish to have here. And what I'm going to do is on the Model Router, I'm just going to show you what it looks like. So this is the Model Router, and I've got the playground. So anybody who's used to working with any models have these experiences where you can go in and start to like interact with this. I can give it a system prompt, which is like the instructions. I can give it a chat prompt, and it will chat back. I can see details about the model. So where it's deployed, you can see it's deployed as a global standard. So I've been a bit cheap with this. I've gone for the most available service. You can see the tokens. And again, these are blurred out because I've got a little extension called AZ Mask turned on. So I don't want to show my keys. This is my key. And again, you can see when this was deployed. What's interesting about this is I can go into the edit, and this is where I actually configure the Model Router. So I've got this set as balanced, but I can either have it as quality or cost. And then I can select the models that I want this to route to. So you can see I've turned all 28 on. If I just wanted to route to a specific model, I just go in and I select the tick boxes for that specific model. Or I can select all the models. So again, I have the control from an admin portal of saying, what does my agent route to? I've not changed any code, remember. This is in production. All I do is, like GPT going away, it will disappear off the list. I'll choose a new model. Or our company's moving to Anthropic, unselect everything else apart from Anthropic. So it gives them that high-level control. I also have the ability to monitor this application. So you can see this is the current demo I'm going to show you in a second. And this is how Model Router is routing each of the different prompts. So this has cost me $17. It's used 13.41 million tokens. So quite a few tokens. And you can see, like I've been bashing it this morning while everybody was speaking, just to see what different random models are chosen based on different prompts. So I can dig further into this and analyze the total number of tokens and the actual cost. This is costing me per token. So again, if somebody came back and said, why are we using this model? Well, we've chose balance, but this is the actual cost. Do you want me to move to quality? Or do you want me to move to a cost basis? And again, it will refactor those models. And again, you've got that transparency of what this is actually costing. So that's a quick overview of the model router and how you can sort of dive in and see that evaluation and observability. So, as developers, you can answer these questions. You can pipe this off to OTelemetry. You can pipe it off to Grafana. You can pipe it to a NOC. That's really down to how you want to orchestrate your implementations. So key benefits are, 76% cost savings we've seen from organizations implementing this. Because again, if somebody opens up a question with hi, it's going to do with a very small model. Then you're going to get to that statement about, I've got this product number with this serial number, our purchase order date, etc. It's going to go to a bigger model. So you get that gradual growth in models. Context is saved in the chat. So again, it's splitting the models, but the memory and context is still there. So you're not going to lose any of the memory and context. Again, it's really about, these key factors. If you want it to be more cost effective, you want it to be balanced, or you want it to be quality. You have that granular control. So, some of the challenges that we talked about, building a solution to choose the right model. Really difficult, really difficult. The types of queries and responses. So anybody who's got an agent, do you have evaluations turned on? And are you looking at the traces to see what people are asking the agents? Honestly, this is so important. Turn tracing on. Just grab that data, stick it into a dashboard. Just understand how are people using your agents, because you might suddenly go, 90% of our questions don't really need an LLM. They just need a better FAQ, or they need something just added to the web page just to say, if you've got a query around this, go here. Model router acts as that router in the middle, selecting the right model, and it gives you the most optional output. So when we look at the stages of how this works, number one, model router is not really an LLM. It's a machine learning classifier. We're training this. It's looking at the current services. It's looking at models which are hot, models which are cold. What's the latency? What's the timing? So this is being done automatically as you press, with very, very minimal latency. And I'll show you that in a second. Number one, we're analyzing the prompt. What is the makeup of the prompt? Then we're running some quality estimations and saying, these are the models that are capable. Is it a reason? Is it function calling? Is it multimodal? Then we're purposely selecting the right model. Is it balanced? Is it cost effective? Is it quality? Then we're doing a dispatch and forwarding that response to the appropriate model, and then the appropriate model is coming back with the answer to the end user. So let's have a look at how this works. One of the things that we've been building is an evaluation solution. Oh, so let me just quickly go back to that. So if you want to take pictures of these QR codes, these are the actual source codes. These are the GitHub repos. So this is something that we open sourced, I think, about 2 weeks ago. Might have been last week. Might be 2. Everything's so fast at the moment. But this is one of the questions we got was about, business decision makers want to understand how did the model choose that model and how does it compare against the base model. So what we did, we built this tool that basically is a solution. So it's a set of notebooks, it's a set of Python scripts that you just execute against your model router implementation in your base model and your agents, and it will give you this set of results in terms of that determinism of how effective model router is for your organization. Now, in some cases, it's not going to give you a good response. In some cases, it's going to be like, oh my God, we need to move. This is the key about that evaluation observability. If you don't have this tool, how can you make that informed decision? How can you best, inform your business? So you can see I've run this on an example, and it's come back and said, if I use model router, it's going to save me nearly 10%. It's going to be 1.5 times faster, and it's giving me the latency of the P50 or the P90 and the reliability as well. So again, this is really coming back to those key things of groundedness, relevance, and coherence. It's giving me a cost comparison. So I was using GPT-4o. Model router has a cost saving as well. And I can see the latency difference between the base model and the model router. And I can see the latency distribution, etc. So this is just like a quick observability dashboard that you can just have running. Business decision maker asks you a question. This is why. This is the answer to why we chose that model. So again, completely open sourced. Download it, give it a play, and see what benefits are. So it's called Model Auto Router Evaluation. It's a HTML dashboard. You can host it. You can run it locally. It produces a full markdown report. has full machine readable outputs. It stores everything in JSON if you want to pipe it to Graphena or if you want to pipe it to an analytics system. It's built with the Foundry Evaluations SDK, so it has that evaluations and observability in there. But again, it's about that evidence piece. So the next thing I want to talk about is a couple of scenarios. So does anybody do like legal contracts, like processing? Any of your organizations? You definitely do. He's going to go, oh my God, in a minute. So, if you think about any form of like contracts process, it requires multiple individuals with specialist knowledge or roles. Aren't they agents? Yes, they're agents, You saw it earlier from Alex. He said, split disciplines, split your agents into specific domains and specific roles, security boundaries. It requires some form of understanding of the context, like documentation summarization or contract reviews or risk reduction or even insights and analytics. So what we want to basically do is look at how a multi-agent solution actually works in an example. So first of all, we're going to have these different agents. This is a multi-agent solution. So we've got a UX agent who's going to be what we call the orchestrator. He's going to guide the other agents to make the right decisions. And if it doesn't make the right decision, he's going to ask a human in the loop to be that to be the exec authority. We've got a policy and trust agent. So that's going to understand the legalities of this and say, no, you can't do it because of this, and these are the reasons what we need to do to deliver it. We have a delivery agent, so our postman, who's going to route and deliver the actual outcomes of the agent. And then we've got a document agent who's going to analyze the contracts to make sure they're valid, appropriate, correct. And then we have an escalations agent who's going to handle escalation. So this is a typical architecture of a multi-agent solution that's going to guide us through this process. Again, why multi-agent? Context-aware decisions, policy safety, the human in the loop is so key. And again, that full auditability of what was actually done by who, by when, etc. So this is our example, okay? So we're going to basically send an NDA to 12 partners. So as I said, this is a process of the agents. We're going to have some issues in this because we're going to try and send NDAs to countries who have legal exceptions or legal terms that we need to comply to. So we're going to have like some form of human in the loop to do that validation, and then we're going to actually send those off to the end users. So if I just move over to this demo. So this is my intelligent agreement demo. As I said, what we're going to be doing is sending an NDA to 12 partners. Across the top, you can see each of the agents. Okay, this is going to be really fast. So please keep an eye on it. As the agents hand off, so orchestrator is the controller, and it's going to hand off to the other agents. So you'll see the agent color turning blue as the work is completed. Think about this like today in your organization. How long would it take to send NDAs to 12 partners? And I'm going to click go. Okay. Go. Okay, so you saw it hand off to each of the agents, and each of the agents that was called is now in green because the process has been run. So it said, great, created 12 NDA contracts. You can see the auditability. So it said, yeah, okay, action. Create and send envelopes. The template, so it's going to use the mutual NDA agreement. It's going to send it to 12 people, and there's a deadline. It's going to then require ID verification per each signer. So it's going to go into the database and check, is there an appropriate signer for that company to sign? And if there's any missing details, it's going to try and suggest details, or if it doesn't know, it's going to use the orchestrator to hand off. So it's created the 12 templates. It's found all the company details, but it's missing 2 titles that require authorization review. So then it's handed off to the policy agent to review those 2, and he's saying, oh, yeah, there's a partner in Japan who requires a Japanese-specific data processing amendment, and there's a partner in Germany who requires GDPR amendment. Okay, so then the orchestrator then says, okay, yeah, I understand that that's a blocker. I now need to call the human in the loop, and it's come back to me as the orchestrator and the manager of this to say, do I approve it? Do I want to look at it? Do I just want to approve and send it? So I'm just going to approve and send. When I click this, it's going to then carry on the process. So I click approve and send. It's now delivered them, and it's now created the comms dashboard. So if I just scroll back up again. So I approve it. It's now gone to the delivery agent. It's created the 10 standard, and it's created the 2 partners with the amendments. And it's done the delivery confirmation. It's going to also set up a schedule that will remind them in 25 days. And then an escalation trigger if they don't sign it after that amendment date. And then I've got a full audible track of what actually happened. So I can see, bulk NDA sent, 12 more. So this could be sent as a Teams message or a Slack message or an email to say, like, this job has been processed. And then I've got a full audit trail of each agent's roles and responsibilities. And that did all that in about 23 seconds. So you've gone from like a week of work to 23 seconds using multi-agent. You've not replaced anybody because there still needs to be experts who build this content and validate it, but you've made them much more productive in what they can do. So if you think about where we're going to go next, it's like we've got Foundry, we've got our support and services. Now we want to build an agent. So we actually want to build and publish this agent and make it available. And this is really where the Foundry hosted agent service comes in. So this is a one-button click, publish of my agent to a hosted container, which is fully scalable, fully managed, fully audited, fully accessible. Again, we support Python, LangGraph again is supported. We support C# as well. So at the moment, it's Python and C# in terms of the native languages that we support. It builds on a custom container, so it uses a Docker-based image. You do not need Docker licenses, okay? So we actually host a Docker Cloud build service. So we have a CLI called Azure Developer CLI, which allows you to build and publish those applications with a single command. You just do AZD up, and it will take your agent container, wrap it in a container, ship it to Azure, host it in the hosted agent environment. So what we're going to do is we're going to look at this from a multi-agent scenario. Does anybody run like network operation centers, call centers, anything like that? Okay, so this example is a multi-agent solution for an on-call engineer support system. So this is the architecture of the actual agent solution. So we have a client-consumer, which is basically just a website. We have the application layer, which is our agent, and our agent is going to call multiple services. So what we're going to do is we're going to take an app insights error. So has anybody done any like Graphena, JSON monitoring? Anybody done any of that? Anybody tried to like look at a JSON and try and figure it out manually? Pretty complicated crap. Okay, so we're going to take that JSON import, run it through these agents, and then create these different views as a network operation center. And we're going to use Model Router as the model for that implementation because we might have stuff that's very small. We might have stuff that's very complex. We want to basically orchestrate between all those different services. And we're going to use services we're going to use app services and container apps for our backend data and services. We're going to use our Foundry agent for our hosted agent. We're going to use agent framework to orchestrate those agents together. We're going to use a model router to be the model inferencing provider. We're going to use app insights to do the tracing and the monitoring of giving us the insights from our services. And we're going to use Key Vault for the security and the protection of the environment because we want it all secure and stored. So again, if you want to take a QR code, this is a demo you can play with. This demo was in dark theme this morning, wasn't it, Eric? And I was like, oh my God, dark theme doesn't work very well in here, so Copilot, make it light theme. Okay, so we'll switch over to the demo. So this is our on-call Copilot. So in this demo, you've got various different demos, which are basically based on an app insights message. So these are JSON records coming from our system monitoring tool. So app insights in our case is our monitoring tool. And you can see this is a fairly complex JSON schema. That one isn't, but this one is. The one I'm going to use is. So we're going to use S1 for this demo. And this is actually an incident on a Redis cache cluster. So the title is Redis cache cluster unresponsive. And you've got a day in the schema. And then you've got this detail of what the actual issue is. And it's quite long. It goes on. So it's like it gives you the memory, the resources, the run book for the technical support teams. What we have here is our network operation center. So we've got various different roles. We have triage, we've got summary, we've got our communications, which is going to be Slack updates to stakeholders, and then we've got a PIR timeline. So we're going to escalate and understand where this issue is to basically confirm and inform users of that process. So I'm just going to run this. This takes about 72 seconds to run, okay? Which sounds like a long time. But how long would it take you to do this manually? And while that's running, I'm just going to jump over to this, and I'm going to show you, while this is running, our hosted agent. So under agents, I've got 2 agents in this environment. So I've got a voice-based agent, and I've got the on-call multi-agent. Just to go back a second, key things about agents is 2 forms of agents, okay? There's prompt-based agents and hosted-based agents. Prompt-based agents are typically just like single user chat. So if I just go into the voice agent, this is a single user chat, but it's literally a voice agent. So I can say, hi, can you tell me what the day is today? Oh, do allow. Hi, can you tell me what, oh, hi, go on, do it. I'm muted. Hi, can you tell me what day it is today, please?
Today is Thursday, June 18th, 2026.
Okay, so that's just a prompt agent. What's really cool about Azure is to make that a voice agent, I just click one box. It sounds bizarre when you do that. So this is just that box I clicked, voice mode. Didn't have to build anything. I just turned it on, and it is now a voice agent. So that's quite a nice feature of prompt-based agents. Very simple tasks, one step, very, very quick to use. This is a bit more complicated because it's a multi-agent. What I want to just show you quickly here is under monitoring. We talked about monitoring evaluations a lot today. And this is an example of how this monitoring is happening on this agent. So you can see like the details of the agent, what it is, where it's hosted, the endpoints. Again, they're blurred out because I don't want to show you where those are. I can also see the traces. So you can actually see the traces that are happening at the moment. So if I can go into the trace, you'll see it's only a single call because I'm calling one agent, but the agent is multi-agent, but I can see the traces of that agent, what the input was, how long it took to actually respond to that response. So I've got the immediate traces there. I've also got monitoring the system, so I can actually see operationally the number of tokens that are being used and the number of runs that are being used. And I can also see the evaluations. So I've set this up with a number of different evaluations, but I've also configured a custom evaluation based on the JSON templates. So when I go into here, I can see like it's coming back with 100% fluency, 99% coherence, 53 task completion because it's a bit vague, the task. All it's doing is analyzing that JSON. But then I've got a custom one called S1 because I've trained this on the S1 demo and the JSON types. And it's come back with 100% pass rate on that. So I'm evaluating this agent, and I can go into each of these agent runs and see like what was the change I made in a release. So I've got that full observability. So if we just go back to this, it's run, which is cool. So this is run, so it took 33.6 seconds. So it was faster than what I thought, what I've been benchmarking previously. So I've got everything already filled in. So I've got the root cause. So it's saying it's actually memory exhaustion on the Redis cache. It's 85% confident. It's then giving me some evidence of why it thinks it's confident. It's giving me the infrastructure failure and saying it's this actual pod, which is down. I can then actually see like a summary of the incident of what actually happened. So this, again, is written in English. I can see the current status for the knock, that it's ongoing. It's got 94% service error rate, so we know it's definitely out. Somebody's got to go and fix it. I've got a communications that's been sent over Slack. That's gone to all the users of that system to say this is the current issues. And then I've got a full time log of the issues that are happening. From a service support perspective, I've also got actions. So I've got actions that the support team have been messaged to say, go and do this. So number one, go and check it. Is the light turned on? Next one, verify that the VM pod health, do the following commands. It's actually giving me the commands as well to run. So I could have another agent running these commands automatically. It's saying, go and inspect the logs, check the nodes, monitor the sessions. I've also got like any missing info. So like what is actually missing? Is it labeled right in the data center? Is there a tag on it? Is it been identified? And then I've got a support runbook that the support teams have to go through to ensure that all the gaps are done. And this is being done by an agent. It's saying, is there any guidance or anything missing? So I automated that complete network operations center with a multi-agent solution, and it's gone from that initial diagnosis to a potential fix in 33 seconds. Pretty impressive from a multi-agent solution. So this is why you should think about multi-agents. So let's look at some of the advantages. Number one, cost efficiencies. We've shown that by using Moderator, we're going to get the most optimized. We're going to have better outcomes. We're going to have a better streamlined model operations process and applications process. And overall, it's going to be better for all of us because we can go back with grounded and relevant answers to why did we choose this. One of the companies that we've been working with is Proficient. So they've been utilizing Moderator through private preview. They've had really impressive results. So, in both in terms of stability, reduction in times for responses, so, better latency. They've used massive diverse workloads as well, which is quite interesting. And again, they really wanted to go from a cost optimization perspective for their agents. So they turned it on via cost. So next steps, start with a balanced model. Always start with balanced models, start with benchmarking. Observe your agents, understand how do they work, how you're monitoring, what the evaluations are. Really, really key. Without monitoring, you're going to be on a losing battle. Use a subset of models. Don't turn all 28 on. Use a subset to understand, which is best, why, going back to those model reasons. And always pick 2 models. Don't just go with a single model because you'll have no failover. So 2 models is a minimum. Because if a model goes down or a model gets deprecated or there's an issue, it will automatically switch to the other model and at least you'll get a response. So if you're interested, visit this repo. So again, another QR code. All the docs are there. Again, you can try Moderator out. It's a great little tool. We're doing lots more to the service. This is a fairly new service that my team's building. We're going to have really some nice new features coming online very, very soon. Also, we run communities. So if you're interested in learning more about this, I lead the Discord community for Microsoft Foundry. My team, I'm usually always in there, a bit sad. But we do have this resource. So if you're interested in joining the community, we have a community on GitHub, or we have a community on Discord. So huge thank you.
All right. Thank you very much. You had a pleasant session. And
We've got 5 minutes.
Yes, 5 minutes for questions. So who wants to start? Who is going to address the first question to Lee? Okay, we have someone here. Just wait a second for the microphone to arrive in the middle.
So I'm really wondering if the model router has any agent or what is the mechanism behind it?
So it's a reinforcement learning model that's trained. So we're basically looking at telemetry coming off our systems to then do predictions based on the telemetry. So it's not an LLM, it's a finely tuned model.
Yeah. Mm-hmm. Okay, good. Thank you.
So is anybody using Open Router? One person. I spoke to you over lunch. So Open Router is an open source version of this, but what we've done is looked at the telemetry that's coming from our Azure infrastructure and data centers to then have that really, fine-grained cost, quality, and performance data. Because if you think about, when people, deploy models and implement models, everything is running on physical compute at the back end. So there's literally servers that are going hot and cold. When I talk about hot, I mean the server's been turned on, it's being utilized, and it's been inferenced within the last 3 milliseconds. Whereas anything that's cold is less than that. So we're actually saying, look, this is hot, it's been used, that model's on there, use it, bump. So you're getting instant, super fast latency. And this is being done at a millisecond level. So the latency that you actually see, you don't see it, which is pretty incredible. Thank you to Microsoft Research.
Any other questions? Okay, we have one there. Let's wait for the microphone to just arrive to you.
Sorry, I got the microphone first. So you mentioned that the model router is having currently 28 models, and you can option based on whatever model you want. How do you know which model to choose, and how do you know which model is more performant than the others?
You're back to the 11,000 question. So benchmarking is key. So in the Foundry portal, we actually have a benchmarking section. Let me just quickly show you. So when you go into your deployments and models, you get this dashboard. And what you can do from here is you can see 11,000 models, and you can also then start to not fine-tune, but specify based on different tasks. So you can see that each model is categorized into a specific task or a vendor. You can actually then compare models. So again, you can do this human evaluation. So in this case, I've got a few different models here ready to go. And I can give that prompt, the same prompt to all three models and see what the responses are. So I can visually analyze it. And I also have these weightings of quality and benchmarks that Microsoft has provided. You also have a view leaderboard and dashboard, which is looking at model benchmark, which is like an open standard report, and then overlaying Microsoft benchmarks onto this, so then you can see where these models sit, and you can select specific models, all models, etc. So we provide a lot of benchmarking and discoverability tools to allow you to make that an initial assessment of which model to utilize. So I hope that's sort of answered the question.
Yeah, thank you.
Hi. A question regarding the...
Sorry, stick your hand up. Where are you?
Here, right here.
Oh, right, okay. Sorry.
Hi. So I was, you just showed basically you have three categories of configuring the models, either for balance or for quality, or
cost,
whatever.
Yeah, cost, quality, or performance.
Okay. Is it possible to be able to define custom criteria? For example, I want to use a subset of models for a certain task and only choose between those? Or...
Yes, exactly. Yeah. So when you build your agent, you would have different model router deployments. So you would deploy, so like say, for example, you've got 3 agents in your solution. You're doing exactly what you've done. You defined what that agent's role is. You would deploy 3 model router implementations. In each implementation, you would only select the models that agent should utilize. So you can have unlimited number of model router deployments, but that's a recommendation we would make, is have a model router deployment for that agent with only the models that you want to utilize for that agent. And then you get the cost for one agent, you might get balance for another agent, you might get performance for another agent. And they might all be using different models. Or they might all use the same model, but you want to do cost-quality balance.
And then one other question, if I'm allowed.
Yeah.
I saw there, are you able to, for example, if I build my own model, I'm not, but let's say, can I upload it and use it in Azure Foundry? Can they host my, let's say, my model, not like a frontier model?
Yeah, so you can host a fine-tuned model or a custom model today in Foundry. It just sits within the container store. Today, you can, and I stress, today, you cannot use it within Model Router. Today.
But next week, maybe we can. Thank you.
But yeah, that's definitely, and that scenario is really popular in automotive. So anybody driving Mercedes or a BMW, they are using fine-tuned custom models for Mercedes, me, BMW, and they want those models to be selectable from different services. Robotics is another one, A, B, and B, robotics. Any other questions? One more, I've got 30 seconds.
We have one more in here in the front.
how the customers are charged for using Microsoft Foundry?
Yeah. So for Foundry or for Model Router?
If there is for Foundry and for
So if you're a Foundry customer, you're billed on token consumption. So you either have an enterprise agreement of $10,000, or you're on a pay-as-you-go subscription, you just pay monthly. If you are using Anthropic models, you have to use a marketplace service, and Anthropic bill you each month for Anthropic models. But again, it's a build model. And again, for Model Router prices are based on the model. So when I went to the analytics before, let me just quickly go there. So when I went into the deployment of the agent, of the model, you actually build on the utilization of those models. So you can see I'm billed £1.38, $1.38 for 13 million tokens, which is pretty good, isn't it? So you build for that usage. And again, if you highlight over the actual individual models, you can see the price you're paying for each of the individual models. That's not going to be on your full statement. That's something you have to telemetrize. But that's what I'm saying. It comes back to that cost, quality, performance. You've got the visibility. Hope that helps. Cool. Thank you.
Well, let's give a big round of applause. Thank you.